Have you ever felt like that sudden ice-cold panic of a team member running a critical infrastructure update straight from their laptop?
Oh, in a coffee shop.
Yes, in a coffee shop with a zero audit trail, just some rogue engineer hitting enter, the Wi-Fi drops for a second, and suddenly your entire production database is unreachable.
Yeah, that's the nightmare scenario right there.
And nobody knows what code was run or what credentials were used or honestly how to roll it back. Well, welcome to the deep dive. Today, we are looking at a stack of sources, including the official Terraform Cloud documentation and the Terraform Associate 003 certification exam notes.
Lots of good stuff in there.
Right. And our mission today is to equip you with everything you need to master team-based infrastructure management. Whether you're, cramming for that certification exam or just trying to scale your team's operations without breaking anything, we want to figure out how to stop that coffee shop scenario from ever happening.
Exactly.
Okay, let's unpack this. How do we move from the wild west of local machines to a secure, visible, central command?
Well, because the reality of how teams actually operate day to day, it almost never matches those pristine diagrams we draw on whiteboard.
Oh, definitely not.
Right. There is this massive, honestly terrifying gap between an individual developer's productivity and a whole team's safety. When you're just one person, the open source tools work beautifully. But when you add like a dozen people, things start breaking unless you change your architecture.
So to understand the central command, what we're going to call the control tower concept, we really have to define the open source status quo first, right?
Yeah, that's the baseline.
So Terraform open source software, or OSS, is the foundation here. It lets you write configuration files, those files ending in .tf, that act as the blueprint for your cloud infrastructure. You type out that you want, say, 3 servers and a database, you run it, and Terraform builds it.
It's magic when you first see it.
It really is. But the catch is where that execution actually happens.
And that is the crux of the issue. By default, when you run Terraform OSS, the execution happens locally on your machine. Your laptop is doing all the heavy lifting.
Right.
It reads your local configuration files. It uses the credentials stored on your specific hard drive. It reaches out to the cloud provider's API. And then crucially, it saves a local file called a state file.
A state file.
Yeah. That state file is essentially Terraform's memory. It's a giant map of everything it just built so it knows what to update next time.
Which is perfectly fine if you are a solo developer building a side project. You have the code, you have the memory file, you're the only one making changes.
Exactly.
But let's bring in our rogue engineer from the coffee shop. We'll call him Dave.
Classic Dave.
Classic Dave. If Dave and I are both working on the same AWS environment from our own laptops, we immediately hit a wall. I mean, how are we supposed to share that state file if my laptop's memory of the infrastructure is different from Dave's laptop's memory? We're going to overwrite each other.
And that overwrite can be catastrophic. If you deploy a security patch to a server and 10 minutes later, Dave deploys an older version of the code because, his state file was out of date.
Oh, man.
He just silently rolled back your security patch.
That's horrifying.
It is. The control tower metaphor we're talking about today is the industry's answer to this. Moving to a managed platform like Terraform Cloud is about taking that execution, that state file, and that memory and pulling it off the individual laptops into a central command center.
Right. But wait, if I'm on a small, scrappy team and there's a free tier for cloud, why couldn't we just stick to the free open source version and just be really careful about how we manage our state files? Like, say my team puts that state file in a shared cloud storage drive, like an AWS S3 bucket. And to stop the overlapping changes, we just communicate. We talk on Slack, we say, hey, I'm running an update, nobody touch anything, and we just agree to be careful. Why isn't being really careful enough?
It's a fair question, and honestly, it's actually how a lot of teams start out. You can technically use an S3 bucket to store the state file, and you can even attach like a database table to handle locking the file, so 2 people can't write to it at the exact same millisecond.
Right, so problem solved? No.
Well, no. If we connect this to the bigger picture, being careful in Slack is not a scalable operational strategy. And more importantly, it doesn't solve the environment problem.
What do you mean by the environment problem?
When you run that local command, what version of Terraform is Dave running on his laptop versus what you're running? What local environment variables does he have set? Maybe Dave hasn't updated his cloud provider plugins in like 6 months.
Ah, okay. So it's the classic, it works on my machine problem, but instead of just breaking a local web app, it's breaking our actual cloud infrastructure.
It is the exact same problem, just with much, much higher stakes. This is why the defining feature of Terraform Cloud is remote execution.
Remote execution, got it.
When you move to the control tower, your laptop no longer talks to AWS or Azure directly. You tell Terraform Cloud to run the job, and it spins up a pristine, ephemeral virtual machine in the cloud.
Oh,
Yeah, that virtual machine has the exact, standardized version of Terraform your team agreed on. It securely pulls your code, it runs the plan, it applies the changes, and then that temporary machine destroys itself. Dave's outdated laptop plugins no longer matter because his laptop isn't doing the work.
so the laptop basically just becomes a remote control.
Exactly.
I press a button, but the actual heavy machinery is safely behind a fence in the cloud.
That makes a lot of sense. And I imagine that completely changes the game for auditing too. Because in the open source world, if Dave breaks production, the only record of what he did is sitting in his terminal history on his laptop.
Which you might never get access to, especially if his laptop dies or he leaves the company.
With remote execution, the central platform keeps a permanent cryptographic record of who triggered the run, the exact code they used, and the full console output of what was built. You get an unbreakable audit trail.
You know, I was actually looking through the practice questions for the Associate 003 certification exam, and there's a scenario that perfectly targets this exact operational pain point.
Oh, really? How's it set up?
It describes a team struggling with frequent outages because engineers are deploying from local machines, they're stepping on each other's toes, and leadership has zero visibility. It asks what specific features fix this. And based on what you're saying, the answer isn't just about moving the state file, it's about remote runs and central state management working together.
Yes, that is a very common exam concept. The exam wants to test if you understand the underlying mechanism of team-based drift. State locking, which happens automatically in Terraform Cloud, prevents the race condition of two people applying at once by checking out, like, a digital lease on the file. But the remote run is what forces all the execution into that centralized, logged, pristine environment. You have to understand both halves of the solution to really master the control tower.
Okay, so we've established why the open source model falls apart for teams and why we need this control tower for remote execution and state management. But that brings us to the next massive decision in our sources. We know we need a tower, but we have to decide where that tower physically sits. And the exam notes draw a very hard line here between two products, Terraform Cloud and Terraform Enterprise.
It is a critical fork in the road. From a pure software perspective, Terraform Cloud and Terraform Enterprise are the exact same application.
Wait, really?
Yeah, they provide the same remote execution, the same state locking, the same user interface.
Yeah.
But the delivery model, how you consume that software, is entirely different, and that changes the security posture completely.
Let's break that down. So Terraform Cloud is a SaaS product, software as a service. So HashiCorp, the company behind Terraform, hosts the servers, they patch the operating systems, they manage the database.
Right, they do all the maintenance.
My team just opens a web browser, logs in, and starts working. It's incredibly convenient. But Terraform Enterprise is self-hosted. They essentially hand you the software installation of files, and you have to go install it on your own servers, managing the infrastructure that manages your infrastructure.
Which sounds like a massive headache unless you have a very specific reason to do it.
Right. So it's like renting a highly secure apartment in a high-rise, which is cloud SaaS, versus building your own private bunker enterprise where you control who has the keys and where the security tapes are stored.
That's a great way to put it. And for the vast majority of companies, the high-rise is the right choice. It frees your engineering team to actually build products instead of, maintaining the deployment tool.
Yeah, that makes sense.
But let's talk about the bunker. Terraform Enterprise takes that exact same apartment layout, but you build it deep inside your own private network. You own the physical servers, you own the network routing. Most importantly, you own the data storage.
But why would a company go through all that extra operational overhead just to run the same software?
What's fascinating here is how organizations balance the ease of SaaS with regulatory compliance. The enterprise version caters specifically to organizations that are legally barred from using SaaS products for their core operations.
Oh, like banks or something.
Exactly. The exam focuses heavily on two specific features you only get with enterprise. The first is strictly on-premises audit logging. If you're a defense contractor or a highly regulated healthcare provider, your security policies might legally mandate that logs detailing your infrastructure vulnerabilities absolutely cannot leave your corporate network.
They can't go to HashiCorp's cloud.
Right, you cannot send them to a third party.
Because if the SaaS provider gets breached, suddenly someone has a map of your entire internal network architecture.
Precisely. The second major feature is custom single sign-on, or SSO, integration. Many legacy financial institutions have proprietary, internally hosted identity providers. They aren't using a standard cloud identity service like Okta or Azure AD. They have something custom-built behind their own firewalls.
Oh, I see.
Terraform Enterprise can hook directly into those air-gapped systems because the application itself is sitting right next to it on the internal network.
Thinking about the certification exam again, I can easily see how they would turn this into a trick question.
Oh, they definitely do.
Like, if a scenario describes a bank that requires all infrastructure configurations to remain within a zero external egress network perimeter, meaning no data is allowed to touch the public internet, and they need to integrate with an internal SSO tool, the test is basically trying to bait you into picking Terraform Cloud because it has the word cloud in it.
And that would be an automatic failure on that question. You have to recognize that SaaS inherently requires internet egress. The moment you see internal network perimeter only, Terraform Cloud SaaS is off the table. Enterprise is the only correct answer. You have to know when to recommend the high-rise and when the law requires the bunker.
Okay, so we've got the control tower built, whether that's hosted by HashiCorp or sitting in our own data center. Now we have to actually organize the work happening inside it. And this leads us to what is easily the most notorious, confusing piece of terminology in the entire Terraform ecosystem.
Oh yeah, the dual definition of workspaces.
Here's where it gets really interesting or really maddening. They use the exact same word for two totally different concepts. I can just imagine someone taking the exam, reading a question about a workspace, and instantly sweating because they have to guess which definition the test is asking about.
It trips up almost everyone at first.
We need to give everyone listening a foolproof way to tell them apart on a test. Let's start with the open source definition. When I'm in my command line interface, my CLI, and I type Terraform Workspace new dev, what is actually happening on my hard drive?
In the open source context, an OSS workspace is nothing more than an alternate state file existing within your current working directory. It is purely a file management trick.
Just a file.
Just a file. Let's say you have a folder with your configuration files. By default, Terraform creates a state file called terraform.tfstate. When you run that command to create a dev workspace, Terraform does not copy your code. It does not provision a new server environment. All it does is silently create a hidden subfolder, and it starts saving a second separate state file inside that folder.
Wait, let me make sure I'm following. So if I have my AWS access keys hard-coded in my terminal, and I have local variables set, and I switch to this new OSS workspace, everything else stays the same. It's just writing its memory to a different text file.
That's all it is. You're using the exact same local variables, the exact same credentials, and the exact same terminal environment. Think of an OSS workspace like having a single web browser open, but you just opened a second tab.
Yeah.
You're still on the same computer, logged in as the same user. It's just a routing mechanism so you can test some changes locally without overwriting your main state file.
Okay, so an OSS workspace is just a localized file router, but a Terraform Cloud workspace, that is a totally different animal.
It is a completely isolated operational silo. When you click Create Workspace in the Terraform Cloud UI, you aren't just making a new state file. You are creating a dedicated virtual container for an environment.
Wow, okay.
That container has its own specific variables. It has its own dedicated access credentials. It has its own run history, its own audit logs, and its own role-based access controls.
So if OSS is just opening a new browser tab, a cloud workspace is like buying an entirely separate computer, putting it in a different room, and giving the key to a different team. They share absolutely nothing by default.
That is the perfect way to look at it. In cloud, a workspace is the fundamental unit of architecture. You might have a workspace just for the networking layer of your application and a totally separate workspace for the database layer.
Right.
If someone gets access to the networking workspace, they still cannot touch the database workspace because the credentials and state are completely walled off.
There is a classic trick question out there that preys on this exact confusion.
Let's hear it.
It usually reads something like, an engineer is using the Terraform CLI locally without remote backends and runs the command to create a new workspace. What is the result? And the multiple choice options will offer things like, a new isolated cloud environment is provisioned, or a new set of variables is generated, or the current configuration files are duplicated.
And all of those options are traps describing the cloud workspace,
Yeah.
or they're just completely fabricated behaviors. The phrase, using the CLI locally without remote backends, is the massive neon sign telling you they're asking about the open source definition. Therefore, the only correct answer is that a new, separate state file is created within the current directory. You have to look for the context clues. If the question mentions Terraform Cloud, Enterprise, or remote backends, the workspace is an isolated environment. If it mentions local runs, it's just a state file.
So we've navigated the terminology minefield, but let's take this cloud workspace concept, this isolated container, and apply it to how teams actually ship software. Because if these workspaces are completely walled off from each other, how do we move code through a pipeline? The standard pattern our sources talk about is using workspaces to separate environments like development, staging, and production.
This is the most common architectural pattern in Terraform Cloud. You write your infrastructure code once, and you store it in a single repository on GitHub. But then you connect that one repository to 3 different cloud workspaces.
Let me see if I have the mechanics of this right. The underlying blueprint, the .tf files, are identical across all 3, but the workspaces provide the specific context. So the dev workspace connects to your GitHub, but it holds the credentials for the Sandbox AWS account, and it has variables telling Terraform to only provision tiny, cheap servers. The prod workspace connects to the exact same GitHub repository, but it holds the production AWS credentials and variables that say spin up 50 massive, highly available servers.
You've got it perfectly.
Yeah.
You use this workspace pattern when the architecture is the same, but the inputs change based on the environment. You would only use entirely separate code repositories if the actual underlying architecture was fundamentally different between environments.
But wait, this introduces a really painful workflow problem.
Yeah.
In the old open source days, we managed variables by creating a .tf-vars file on our laptop, right?
Yeah.
We just hard-coded the values.
Right.
Now, imagine a company that has 10 different microservices. Each microservice has a dev, staging, and prod workspace. That is 30 completely isolated silos.
30 silos, yeah.
If our security team updates a global setting, say, the IP address of our corporate VPN that every server needs to know about, am I just copying and pasting my TFRs files 20 or 30 times? Because that sounds like an absolute nightmare for a developer. It just sounds like a human error disaster waiting to happen.
It would be a nightmare. And the platform designers knew that treating every workspace as a completely sealed island would cause massive redundancy. So this raises an important question regarding how teams maintain consistency across isolated environments without manual errors.
Right. What's the fix?
The solution highlighted in the documentation is a feature called variable sets.
Variable sets. Okay, how do those function mechanically?
Think of a variable set as a globally managed collection of key value pairs that lives one level up, hovering above the workspaces in the control tower. Instead of defining your corporate VPN IP address or your global AWS access keys inside every single workspace individually, you define them exactly once in a variable set.
And then you map that set to the workspaces that need it.
Yes, you can apply a variable set to a specific group of workspaces, or you can set it to apply globally across your entire Terraform Cloud organization. When you trigger a run in a workspace, Terraform Cloud spins up that ephemeral remote execution environment we talked about earlier.
Right, the temporary VM.
Exactly. It dynamically reaches up, pulls the values from the variable set, securely injects them directly into the memory of that temporary machine, runs the deployment, and then destroys the machine.
Oh, wow. Wait, really? So the sensitive credentials never actually live inside the workspace configuration at all? They're just injected at runtime?
And that unlocks incredibly powerful role-based access control. Your security team can have exclusive ownership of the variable set containing the production database passwords. They manage it, they rotate the passwords, and the developers never even see the values.
That's amazing.
But because the developers have access to the workspaces connected to that set, they can still trigger deployments. The system merges the secure variables at the exact moment of execution. It eliminates the copy-pasting of TFARS files entirely.
That is brilliant. The security team handles the secrets, the dev team handles the architecture, and the control tower merges them safely. So what does this all mean for you listening right now? Whether you are walking into the exam room to get your Associate 003 certification, or you're an engineer tasked with making sure Dave from the coffee shop never accidentally drops the production database again, you now have the blueprint.
We have covered the fundamental shift from local open-source chaos to the centralized safety of remote execution and managed state locking. We explored the architectural fork in the road, balancing the ease of the SaaS high-rise against the strict on-premises compliance of the enterprise bunker.
We finally put an end to the workspace confusion, separating the open source state file routing from the completely isolated cloud containers. And we tied it all together by showing how teams orchestrate dev, staging, and prod pipelines using variable sets to securely inject secrets without driving themselves crazy. You have everything you need to build a control tower.
But before we go, I want to leave you with one final thread to pull on. We have spent this entire deep dive establishing Terraform Cloud and Enterprise as the ultimate solution. It's the central hub that secures, audits, and centralizes all of your infrastructure deployments. It solves the rogue laptop problem beautifully.
It's basically the silver bullet for team-based infrastructure.
It is. But if you take a step back and look at what we've just built, we took absolutely all of our state files, all of our access controls, all of our highly sensitive variable sets, and all of our execution logs, and we put them into one single centralized platform.
Right.
So the question becomes, who is auditing the control tower itself? When does the ultimate solution for decentralized chaos become your single most critical point of failure? It's something to think about the next time you log into your central command.
A slightly terrifying but necessary question to keep us on our toes. That is all the time we have for today. Thanks for joining us on this deep dive. We will catch you next time.